I hope you have a great time yesterday, and I hope you're ready for the next day. So, yeah. Do we see screen already? Yeah. So let's get meshy with the code. Let's get meshy with Kubernetes, Knative, and Event Mesh, and the microservices. So I'm Chris. I work at Red Hat. I work on Knative. That's an extension to Kubernetes that we'll be talking about. I mostly work on Go, Rust, and Java. Well, I'm pretty much open source enthusiast. I do open source all the time. And let's see what we'll be talking about today. So first, I will say a word about transactional and how transactional is misunderstood and how we misuse it. And then I will show about the eventual consistency, what it is, and how we could fix the problems. And about the service mesh and how service mesh isn't really the thing that you could rely on while you're building microservices. And also about CQRS. And of course, Event Mesh, the topic of today. And the implementation of Event Mesh in Knative, of course. And of course, demo and the code, that's the meaty part of this stuff that everybody wants to see. So let's start with transactional. Well, this is, of course, everybody is saying, what you're saying, like transactions are everywhere, but actual transaction, the complex ones, the real one transactions are really rare. Like I could imagine, I could like recall maybe once or two times in all of my career, anybody ask me to actually build application that will do those two operations, or none of those operations should be applied, right? That's rarely happen. So instead of that, we enforce that behavior on our apps and on our businesses as well. And that distorts the business logic because, well, the apps and the business are not really transactional. They are different. Like if you are, for example, buying something from shop, it doesn't matter that the invoicing system doesn't work, right? You wanted to buy something, and this matters. It's not like if the invoicing system doesn't work, the seller will not sell you the thing that you are trying to buy, right? It's not like that. So that's causing a lot of errors, and it's slow as well. And let's see this example. I hope it's kind of visible on the screen. So this is a real application that I took from my colleague. It's written in Java. And this is an actual application that is doing the CAPS, like Uber-like style application, right? So we have here a complete transit method. And in this complete transit method, you could see the first thing that is written on the top, right, is transactional. And what does it mean? Well, it means what it's saying, right? So every operation inside of this method will either succeed or none of those will actually apply it, right? So we are forcing here transactional behavior. And this is not the real world, right? If you imagine if you are exiting from the cab, right, that actually happened. And this doesn't matter, like there is, for example, our service that's registering your miles, right? And this has an outage, right? This doesn't matter. Actually, you have exited from the cab and that happened, right? Yeah, so I marked in red here different operations, actually different things that will be changing in this method. All of those have a chance of failing, of course, right? And here is the actual thing that matters. So this complete transit is the thing that actually happened, right? The transit was completed. So this is actually the concept of eventual consistency, how we could apply it here. And what does it mean? Well, the eventual consistency is a guarantee that when you update is made to the distributed system, that update will eventually be reflected in all reads, right? So it's obvious. And how we could achieve such thing? Well, one could think that maybe splitting those services into microservices could help, right? So let's imagine what will happen. Imagine we magically done that and split it, right? So I make different colors as a different services, and imagine all of those colors are now separate services running on Kubernetes, right? So we will have now 12 remote calls to 5 different remote microservices, right? And thinking like any of those services has really good uptime, like 99.99, that means we have this method is reliable only up to 99.88. So that's kind of low already, right? And this is just one method, right? And it's, of course, at least 1,000 times slower. And still, we can lose data as previously or even further. And, of course, service mesh could help, right? Well, not really, right? Service mesh could only raise this uptime value here up to 99.99, actually. Like, you cannot raise that value to 100%. It will eventually fail, of course, right? So you cannot do that. So service mesh, one could say, okay, let's drop service mesh in between. But, well, it will eventually fail. And we shouldn't really use service mesh for the synchronous remote call apart from queries, right? So queries are safe, but those changes are not really. Like if we are sending some message and there is a chance of losing that message, well, we are not doing our work correctly. So CQRS stands for Command and Query Responsibility Segregation. And how this could help us, right? Well, it divides our application into 2 parts, basically. One is a command, and the second one is query, right? The command is asynchronous. It's kind of like events, of course, and we need to make sure that we don't lose it. And the query is synchronous. It's a request-response operation. And it's safe to retry in most cases. It should be safe to retry. Yeah, and an example in our situation, what will be the change that we made? Well, instead of having this method, we'll create events, right? So we have complete transit event, that is the root event in this example, and then we will have another sub events like update destination that could happen or not. Calculate fee for the driver. Driver is free for taking another drive. We are registering miles in some additional system, issuing invoice, right? All of those operations are additional commands, additional events. And of course, there are other queries like read transit, read address, and so on, that could happen in between. And event mesh, right? What is an event mesh? Well, event mesh, you should imagine event mesh as something that is sitting outside of your application, that is configurable, that is dynamic, right? So you could configure that dynamically, and it is distributing those events between those applications in that way that those applications doesn't really know where they are sending those messages, right? So the application is just sending message, and the event mesh is handling the message, sending it to the destination, retrying whenever it needed, and so on and so on. So application are not aware of any of that processing. So that means it could be monitored, it could be flexible, it could be reliable, and it could be, of course, fast as well. And here is some comparison between service mesh and event mesh. Well, both of those have the same similarities like flexibility, robustness, decoupling between applications, but there are key differences, right? So service mesh is for synchronous operations, for request-response type of operations, and it's better for queries, right? And event mesh is actually, well, basically a synchronous thing. It's eventual consistent thing, and it's based on events, of course. And of course, it's because of it's based on events, it's better for commands. It's natural. So let's talk about the Knative. In OpenShift, it's called serverless, but the Knative, this is the CNCF project. It's a Kubernetes extension. This is our mascot. Pretty nice. Like we get that lately. So it allows you to deploy serverless applications on top of Kubernetes that will scale automatically up and down, and also brings this event mesh as well. So Knative in OpenShift, as I said, Knative is CNCF project. It's community-driven, supported by those companies. Currently, mostly by Red Hat, unfortunately, but yeah, all those companies have contributed, and they are still contributing. We have production release for like 3-4 years now, so it's pretty production ready, I would say. Yeah, and let me now switch to demo mode. So I will be showing what you could do with that application, right? So I have here the same method that I was showing before, but it's already rewritten. What you could see, of course, there is no transactional in the beginning. That's first notice. And I wanted to just extract one functionality to basically keep consistency with the previous example and not to lose your attention. So I picked the drivers service, and drivers are managing basically information about drivers, right? That's one thing. So I extracted the driver service, and driver service is now separate Rust. I have written that service into Rust code, so we have that. And also, one method that I will be showing here is this one, the calculate driver fee, that has been rewritten into events. So let's see first maybe how it's looking. Here I have those applications already deployed. So yeah, here we have this drivers service, and here we have this legacy Java application. Yeah, and let's jump to the code. Let's see this method, right? So how this method is now implemented? Well, it just publishes an event, right? How it is done. When we go here, we could see like this method is basically creating CloudEvent. CloudEvent is a separate CNCF project that we also contribute to. So basically, you can imagine cloud events as being those envelope around events handling things that every event should have, like ID, source, time, and such. So we are creating cloud event from our information. So we have here this event, right? And we are packing this event into this cloud event, right? So we have basically our information and enveloped around this cloud, inside cloud event, right? And what we are doing here, we are just sending HTTP message, where, well, you could see here we have this URL, right? So we take the URL from somewhere. I will say in a minute how that is done. So the application is taking the address from somewhere, and it's just sending this cloud event there, right? And if that succeeds, that means the event mesh captured that event and will be doing something with it, right? If not, that means we should raise the exception and probably retry in the next time, right? Let's see what happens on the other side. So we have here the Rust service. I don't need this thing now. Yeah, so the Rust service, this is not this one. Yeah, this is the one. So here we have just endpoint on the root of the application, right? We have a post endpoint to this method. And what you can see here that we are receiving also CloudEvent. This is library for Rust. This is the event that we are getting. And what we are doing with this event, we are basically checking the type. And that if the type is expected by us, right, this is the type that we are expecting to calculate fee, well, we are calling the calculate fee method. Yes, so this is not working for me, but I will need to manually go there. This is the service. Service is here. 1 second. So this is the service. And we have here a calculate fee method, right? And that calculate fee method is, of course, receiving this cloud event. We are parsing that cloud event as a fee event, right? So we have the fee event. And having that fee event, we are calculating fee in whatever like logic we have, right? When we calculate that amount here, we have a money amount calculated. What we are doing next, we are just creating another event, right? The event is called driver fee event. And we are just sending this again as a cloud event. So we are receiving one event, we are calculating something, and we are sending another event back to the mesh, right? So we have here the sender function. And this sender is basically here. So we are sending, and as you can see once again, is just HTTP sent to some post message to some address, right? To something like this. So this is just posting some HTTP message somewhere. So very simple code. In between, we are receiving HTTP messages and we are sending HTTP messages somewhere, right? And basically that's, let's go back to the original application, what the original application is receiving from that. So we have this class that once again is similar to the one that was written in Rust. So we are expecting cloud events on the main endpoint, post on the main endpoint here. And basically we are once again extracting our business event from CloudEvent, right? So our business information. And if we have that business information, we are sending that information. This is actually using Spring Publisher. So this actually is hitting back the same function here, a little bit lower. We have this additional function that is expecting this driver fee already calculated. And if that driver fee is already calculated somewhere, right, we have received that, we are just updating our database in transactional block or normal transactional processing here, right? So we have two applications. One is sending event. The other is receiving that event, calculating the fee, raising another event, and the original application is listening to that event type, the already calculated type, right? So we decoupled those applications already into those two apps, and they are already eventual consistent, as I will show in a second. So let me just delete. Oh, I need to go here. Delete the service mesh that we had and show you once again how this looks like. So we have those two applications sitting there, and there are no anything in between. And now let's recreate this this mesh in between. I will say in a minute what this means. So we are deploying one broker, two sources, and two triggers, basically to this service mesh. And this actually can translate into those things that are visualized here. This is the broker. Broker is like a thing that is holding the events in between, and those are triggers. So we have on these triggers said that whatever that event type is like that, feed it to this application, right? And if the event type is like that, feed it to this application. Simple as that, right? Yeah, and let's try calling those, right? So let's first see the logs of those apps. So first, this is the legacy application, and I modified this application to basically already prepare like development data for me, so I could just easily show you this complete method, complete transit. So basically, I should call this endpoint with data to basically end the transit, right? What we want to do. And let's see also this another application. Oh, this is interesting. It crashed. Shutdown completed. Let's see. I don't know. Maybe that was just the previous one. Yeah, because this is in different color. Right. So we have here this another application in between. The below we have drivers application, and let's open another window to just call that. So we will be getting service describe. Yeah, KN is our command line tool. So I'm using that to basically take the address of this legacy application. And I will be taking that to basically build my request. So I'm sending HTTP request to this transit method, right, to complete this operation, right? This will happen fairly quickly. So let me clear the screen like that. And I'm sending the message to the legacy application. The application will send an event to the mesh. Mesh will transmit that event to the second application that will calculate the fee, create another event, send it back to the event mesh, and event mesh will send the event where it's configured, and we will expect to see the message on the legacy application. Right, so we could see like we received something, and another application calculated the fee. We could see that here, that this has been calculated, and the message with another event was sent back to the mesh. And here, if we scroll a little bit, here we could see the driver fee has been calculated, right, for this operation. So this is another operation, you could jump here a little bit further to see this is actually another request, right? So there was first request, and this is the second request coming from the mesh. So we received that. The broker here is could be backed by Kafka in production scenarios. So whenever we are sending events to the broker, we are making sure that those events are safe and will not be lost, right? So, and whenever something is broken in our apps, the event mesh will automatically retry our operation, right? So we already, in this example, built resilient and distributed system without really changing much in our code apart from adapting CQRS and events, basically, right? So we are already done, at least this part. Yeah, key takeaways from this. Don't force transactional processing everywhere, right? We used to do that in all sorts of places, but it's not really, as I showed, it's not really the thing that we should do. We should make sure to persist the events. Like in our example, we support Kafka as a direct place to store the events in the broker, in channels. So that's a good idea. You could use another implementation, of course. Decouple apps, that's always benefit to have those apps decoupled in this way. This is a good way to do it, I think. And of course, Event Mesh makes distributed apps easy in this way. Like, we don't need to adopt any like greenfield approach here. You could see I just take legacy application and start using events, right? So you could do that anywhere, really. And you could use eventual consistency just today, right? You don't need greenfield project to use something like another approaches, right? This is simple, right? We are just pushing things to be done to the mesh, and we are reconciling those things onto our apps, onto standard databases. Just like that. Simple, right? Here are a couple of resources about Knative, about this example as well. And thank you. Any questions?
Thank you, Chris. Yeah, there are a couple of questions. Let me read them for you.
Yeah.
So, first one. Splitting transaction to set of independent events is beneficial from technological perspective, but is it not an increase in product support on the flip side?
Well, I just showed like in most cases, this is actually closer to the business case than having everything in one transactional block. Because, well, our world isn't transactional. Our world is eventual consistent. And our businesses are like that. So we should model our systems in this way, not transactional way. So this is closer to the business, and this is already a selling point for businesses, selling, okay, we should rewrite this part of application because, well, it was written badly, and it should be closer to what you're supposed to do, right? And it's supposed to be eventually consistent because the business is.
Thank you. And the next one is going to be, how does the Knative Event Mesh compare to using the out-of-box pattern with some change data capture tooling that also try to address similar problems?
Well, there are different approaches, but this one is like, for example, people are using just Kafka and use apps and send messages just to Kafka and receive just from Kafka, right? And this also, I could use Kafka here, but this is very very good for developers because we are just sending HTTP messages and receiving HTTP messages. So it's very easy to test. I don't need any additional library. I don't need any additional tooling to test. I don't need any additional knowledge to test. I don't even need to spin up Kafka here. In this example, when I was developing this example, I just spin those applications on my local host and just feed the messages from one to another without mesh, right? So the mesh could be done in the staging on production environment and will give you the eventual consistency and retries and so on, right? But you could easily do that in testing in your development as well. Very easy.
Yeah, I noticed that code doesn't change that much, right?
Yeah, you don't have any additional libraries, dependencies.
This one is not really a question, maybe a note. So things tend to go wrong. Consistently may be a delay to unacceptable time by the business.
Yes and no. I mean, it depends on the case. In most cases, it could be, it's not a no-brainer. And also, this gives us developers, very powerful thing. If you make a mistake here, like something is throwing exception, like for example in this driver service, what will happen? Well, the message will be, the event mesh will receive, okay, something is failing, so I should retry that operation. And we'll try to retry and retry, and you could configure the mesh to keep retrying, until the atomic death of the universe, of course. And you could use that time for your advantage to actually fix the service, deploy the fixed service, resolve service in a couple of days, for example, and then the message will be automatically consumed by the next version of your service, and everything is back to normal. You don't lose any messages, you don't lose any data, you don't lose any business value. You just have this addressed in the secure and easy way. And the business that sometimes needed like direct operation that needs to happen, well, in most cases, they only value something really small, not the whole block of operation. Like we see the complete transit is a block of operations, but they value something very, very small from that part. Like, I need just the money, right? Or something, like they only are expecting this. So you could write another small service, just will be querying this specific part and get that part quicker, right?
Last question. How do you handle events tracing in Knative? Is it something automated by the Knative? Are there IDs injected in the request?
Yeah, Knative supports the open tracing. So that's project from CNCF. We also support the open consort, this is called. Something like that. This is the older library. Yeah, and we are actually in the middle of migrating to OpenTelemetry, but the tracing part should be already working. So you could deploy any open tracing application, just trace events exactly in the same way as you trace request.
Perfect, thank you. That will be all.
Thank you.
Thank you very much.
Thank you.